Welcome to lesson 5.5. The title of this lesson is inverse function, and the objective is to find equations for the inverse of the parent function. A couple of definitions that you need to know. Inverse of a parent function is a reflection over the line of y equals to x. That's just a diagonal line that has a y-intercept of 0 and the slope of 1. So the first thing I would like you to do is on your graphing calculator, put in y1 equals to x. And I'd like you to change your window to a standard window. And a standard window has an x min and y min of -10, x max and y max of +10, and then x and y scale of 1. All right, so hit graph. What you are probably seeing right now is just a line that it's a diagonal line that's running across your graph. All right. Next thing I would like you to do is on your graphing calculator, I would like you to graph y equals to 0.5x plus 2. When you graph y equals to 0.5x plus 2, this is the graph that you're going to get, and you'll notice that this graph has a y-intercept of +2. It has a slope of 0.5, so what that means is up 1 over 2. The rise is 1 and the run is 2. All right. Now, imagine that this line is going to be reflected over the line of y equals to x. So, graphically speaking, let me type it in my calculator and let me show you what it looks like. So the original function, the original line that I asked you to graph is this line that's going up right there. That's in red. And then the inverse of that function is this line that I added into my calculator, which I didn't give you the equation yet. Now imagine that this line is being reflected over this diagonal line of just y equals to x. Okay. Can you imagine that? Imagine that I'm folding this paper down right on that diagonal line. So you notice that the top half is going to be the same as the bottom half. Now, let me show you how to find that equation. So again, let me go back to our original equation. Our original equation was y equals 0.5x plus 2. That was our original function, and it has, again, the y-intercept of 2, and it has a slope of 1/2. All right. Now, to find the inverse function, here's what we do. To find the inverse function, we need to exchange the x and y. Right. So what you're going to get is x equals 0.5 y plus 2. All right. And now we're going to rewrite it as a y-equal equation. So we're going to subtract 2 from both sides. So you're going to get x minus 2 is equal to 0.5 y. And then to undo the 0.5, we're going to divide both sides by 0.5. So when I divide both sides by 0.5, that's really the same thing as multiplying by 2. So I'm going to get 2x minus 4. And that equation, if you type it into your calculator right now, okay, that equation is going to be the inverse of the parent function that I gave you earlier of y equals to 0.5x plus 2. Right? Try it, type it into your calculator, and see if that's true. Right? Let's take a couple more examples here. So on your calculator right now, what I would like you to do is in your y1, I'd like you to put in y equals parentheses x minus 2 squared. So when you type that into your calculator, please notice that that square is going to give it the shape of a parabola, and it has been translated to the right 2 unit. All right. So our goal right now is to find that inverse function, to find that reflection over the line of y equals to x. So using the same method that I just told you, what I'm going to do is I'm going to cross out the x and y, and I'm going to switch them. All right. So when I switch the x and y, I'm going to get x is equal to parentheses y minus 2 squared. All right. I'm going to solve for the y equal. So to undo that square, I am going to take the square root. And when I take the square root, I am going to get the positive and negative of the square root of x. That square root will undo the square, so the last step I want to do is to add 2 on both sides. All right. So the inverse equations, it takes 2 of them. For the original parabola is going to be the positive square root of x plus 2. That's one of them. So put that in for maybe y2 when we're done. And then the other one's going to be the negative square root of x plus 2. And again, put that in for y3. So I know it's not as clear as the line, but here's what your graph should look like. And you will notice that I made the original function, the parabola function, a little bit darker, and that my top half of the inverse function is right there. And then the bottom half is it's a little bit hidden here, but it's right down here. Okay, so imagine that there is a line that is going diagonally across your graph. You'll notice that if I fold it, the top half will equal to the bottom half. Since your calculator screen is not a perfect square, this is the reason why the horizontal lines look a little bit longer than the vertical line, but it is exactly the same. All right, so let me wrap up this lesson. To find the inverse function, it takes 3 steps. One is to replace x and y, not replace, but to switch, I should say switch, x and y. And then the second step is to solve for y. Okay. This will give us new functions. Right. Now, the third thing, this is not something I haven't talked about yet, but the notation. Okay. The notation for the inverse is f negative 1 of x. All right. I want to emphasize that f negative 1 is the notation for the inverse function. It is not the negative exponent that we have been learning so far. Okay. So let me quickly take another one. For example, if you happen to have this function y equals the square root of 3x plus 4. All right. If you graph this on your calculator, you're going to see that it is a sideways parabola that has been moved to the left 4 units, and chances are it has a little bit of a stretch to it. All right. So how do we find the inverse function? So step 1 says we're going to switch the x and y. So you're going to get x is equal to the square root of 3y plus 4. All right. And then we're going to solve for x. So to undo that square root so that I can free up everything that's underneath it, to undo that square root, I'm going to square both sides. Right? And then what I'm going to get is an x squared is equal to 3y plus 4. And then I'm going to subtract 4. Again, PEMDAS backward here. Once I'm done with subtracting 4, I will divide everything by 3. So my inverse function is going to be, and I'm going to use the inverse function notation, f of negative 1 of x is going to equal to x squared minus 4 on the numerator, and then dividing by 3 on the denominator. Right? If I take this one step further and ask you, find the inverse of 2, for example. Okay. So this is the same thing as if we were replacing x with 2. You're going to get 2 squared minus 4 divided by 3. Well, 2 squared is 4. 4 minus 4 is 0. And 0 divided by 3 is going to be 0. So the inverse function at 2 is going to be 0. All right, so copy this down. The notes. First of all, to find the inverse function, switch the x and y. Solve for y. That will give us new functions. And then write it with the correct notation of f negative 1 of x. Okay? For the rest of the hour, I'd like you to work on worksheet 5.5, which is in the back of worksheet 5.4.